All right, hello students, welcome to the virtual Pre-Calc 11 classroom. Today we're going to work on how to solve quadratic equations by factoring. And I've already kind of alluded to this in other videos and we've kind of already done this, but now we're just going to officially go over and specifically work on this skill. So I'm going to share my screen here. Again, you don't have to be taking the notes, but it helps guide the conversations and helps in my opinion, if you do the notes, because you can stop, rewind, try, stop, rewind, try, pause, try, watch the videos. So if a given value is a solution for a quadratic, substituting the value into the quadratic should satisfy the equation. So for this first one, it's actually, we're not solving it. It's saying, hey, the solution here is x equals 3. And right here, that's what x equals 3. Is it a solution? So in order for it to be a solution, it means that we should be able to substitute it in. So everywhere we see x, we substitute in a 3, and our left side should equal our right side. So we're going to do that now. We're going to put a 3 in everywhere we see an x. And this doesn't involve any algebra or manipulation of the equation. It just involves that we follow our order of operations. So that's the lovely bed mass, brackets first, exponents next, then division and multiplication, and then addition and subtraction. If you're one of my French immersion students, it's PEMDAS or PEDMAS for parentheses instead of brackets. Same thing. All right, so we're going to do our exponents first. So that means we have to do this one first. 3 squared is 9. 9 times 2 is 18. Then we're going to do minus 5 times 3, which is negative 15, minus 3 equals 0. 18 minus 15 is 3. 3 minus 3 is 0. Does the left side equal the right side? Yes, it does. So it is verified as a solution. All right, so we're going to do the same thing for this one over here. Instead, it's given us x equals the root 6. So we're going to put root 6 in everywhere we see an x. And we're going to do exponents first. So root 6 squared, or the square root of 6 squared, is just 6. 6 times 3 is 18. 18 minus 9 is not 0. So that means x equaling root 6 is not a solution. So you should be able to determine whether a solution is actually a solution by verifying it, whether that is a given solution to you or the solution that you find. So at any point in time you get an answer, you can plug it back into the original equation, and if it satisfies that equation, then you are correct and you have found the solution. So to solve the factored quadratic equation, solve for x. These are the roots of the equation, not zeros, because it's an equation, not a function, and are the x-intercepts of the parabola when graphed. So because it's specifically equal to 0, we're not just setting it equal to 0 to find the x-intercepts. That means we're looking for the roots, and the only points that are valid on that parabola are the x-intercepts. So the parabola can have either 0 solutions, 1 solution, or 2 solutions. Here, it very much has 2 solutions because there are 2 factors. So we are going to factor the one that I kept highlighted in yellow, because if that bracket is equal to 0, it doesn't matter what the second bracket equals, because anything times 0 is 0. So for x plus 3 to equal 0, we can now solve for what x would have to be in order to make this equal to 0. So we subtract 3 from both sides, and we get that x is equal to negative 3. If we were to plug in negative 3 into the original equation, the first bracket would equal 0, the second bracket would equal 1, 0 times 1 equals 0. Let's go ahead and do the second bracket that I've just put in blue. right? So we have x plus 4 can also equal 0. So we subtract 4 from both sides. And that means x can equal -4. So here are the two solutions for this parabola. And again, there can be two solutions. The parabola goes down and then back up again, or up and then down again. Okay? So pause the video here and try the next one. So x plus 5 equals 0. Subtract 5 from both sides, and you're going to get that x equals -5. And the other one is a two-step algebra. So you have to add 4 to both sides first. And then you have to divide by the coefficient in front of that variable. And you get x equals +4/3. And that's one solution, and that's the other solution. Ideally, you put the solutions in the same box together, but I didn't manage my space very well. So I don't know if you've noticed, but the solution is always the negative symbol, so the opposite symbol of what's in here. So if we look at this one, the solution is -5. Okay, so it's the opposite symbol of the number that's inside of it. And if there's a coefficient in front of the x, that ends up on the bottom. So I don't even have to do the algebra that I just wonderfully showed you right here. I can just take this bracket and say, well, it's -4, so that's going to be +4, and there's a 3 in front of the x, so it's going to be divided by 3, so it's going to be +4/3. So if you can, after you've done the algebraic method after a while and you're more comfortable with it, you can skip those algebra steps and just write out what the solution is. Okay. So in that example, they were wonderfully already factored for us, but what if it's not factored? And it says solve by factoring, and I meant to write equals 0 here, so you're gonna have to put that in there for me because I forgot to do it. So this is equal to 0, so it's now an equation and it's now solvable, so we have to factor it first. You might want to review factoring trinomials. These are simple trinomials. These ones that have the 2 or a coefficient in front of the x squared or a number in the a position are messy trinomials. You might want to review those videos. So here I'm looking for two numbers that multiply to 35 and add to -12 because they're both, because it's a positive product, it means they have to both have the same symbol, and because they have a negative sum, it means that they're both going to be negative. And my numbers are going to be 7 and 5. So that means my solution for m is going to equal 7 and +5, because I just did the opposite symbol up in here. And of course, the number in front of the m is a 1, so they're technically over 1. So for this one here, the next one, C, I know it's labeled the other way. So you're looking for two numbers that multiply to -30 and add to -7. Those two numbers are -10 and +3. So then you can use decomp method, or you can use box method. Factor out each group, copy down the symbol that's in front of the third term, and you get your factored form of x minus 5 times 2x plus 3 equals 0. So that means x will equal, remember the whole thing is going to be set to 0, so you can use algebra to solve for x, or you can do opposite symbol of -5 is +5. And this one, opposite symbol of +3 is a -3, and then this one also has a coefficient, so it's going to be -3/2. Okay. Alrighty, so I forgot to put a box on my answer here. Very important that I do that. Okay, pause the video here and try to figure out these ones. All right, difference of squares. So this is going to go straight into factor brackets. This is 2c minus 7 and 2c plus 7. If you forgot how to do that, review these factoring special trinomials in the Unit 3 section of my website or that assignment that we did for factoring review. So here we have the exact same thing, but different symbols. That means C can equal plus or minus 7 over 2. Okay. If that was a little too fast or you don't understand how I went for that jump, that big leap, it's the same thing in each bracket. So just take one of them. Okay, just take one of them. And it's going to be 2c plus 7 equals 0. Subtract 7 from both sides. So you get 2c equals negative 7. Then you're going to divide by 2 and you get c equals negative 7 over 2. Now if you were to do the exact same thing for this bracket, it will be the exact same thing, except for instead of it being a negative 7, it would have been a positive 7. So that is why your answer is going to be plus or minus 7 over 2. Let's try the next one. So here you have something, it's not a difference of squares, it's not a trinomial, it's just a binomial, but it has something common in both terms. So you can factor y, you can divide both of these things by y, and have y times y minus 11 equals 0. So you still have a quadratic, and there's two possibilities. This y could equal 0, or this whole thing, y minus 11 could equal 0. And it's just like the factor brackets. You're going to add 11 to both sides, and you're going to get y equals 11. So the two solutions to this one is 0 and 11. Now, at any point in time, you want to see if you're right, you plug those numbers back in. So let's just try that with this last one that we did. So we had y squared minus 11y, I believe, equals 0. Yes. So if one solution is that y equals 0, you're going to put a 0 in for y. So 0 squared minus 11 times 0 equals 0. And you're going to get that, okay, 0 equals 0 because 0 squared is 0 and negative 11 times 0 is also 0. So that is verified. And then you're going to check the second one. And you should always check your answers, but I recognize sometimes time is not our friend. So we have y squared minus 11, oops, I jumped the gun here, y equals 0. And our second solution was that y equals 11. So you're going to put an 11 in for the y. And follow BEDMAS. And again, you see that the left side equals the right side. So you have factored this correctly and verified both your answers to be correct. Great job. Pat yourself on the back. Okay. So to solve a complex equation, group your like terms and move everything to one side of the equal sign, then factor, then solve for the unknown. So here we have a bunch of things that are all over the place. We need to move them all to one side. We need to make it equal to 0 because then we can use our factoring skills and our understanding of how to factor with algebra to them. So here I'm going to subtract 3m from both sides. So I'm going to end up with m squared plus 8m minus 3m is going to be positive 5m equals 24. Then I'm going to subtract 24 from both sides. and I'm going to get m squared plus 5m minus 24 equals 0. And then we are just back to where we were in the previous example, example 3, where we factor and solve. So for this one, we have, I think it's positive 8 and negative 3. So we get m plus 8 times m minus 3 equals 0. So that means our solution for m is not positive 3 and negative 3. It's the opposite sign. You're not telling me what numbers are in the brackets. You're telling me the value for m that will make each bracket equal to 0. So m is going to equal negative 8 and positive 3. Pause the video and try the next one. Okay, so I'm just going to straight away move everything to one side. So I'm going to get x times x minus 6 minus 2 times x minus 8 equals 0. I now have to expand those brackets because the factors in the brackets are not the same. So I can't factor from here, but I'm going to hopefully expand, regroup, and refactor. So I'm going to be multiplying each of these things by the coefficient in front of them. So x times x is x squared. X times negative 6 is negative 6x. Negative 2 times x is negative 2x. And negative 2 times negative 8 is positive 16. And that equals 0. Okay. I'm now going to group that middle term because I can't just try to refactor it from here. I'm going to get the same result where I can't factor anything else. So I'm going to regroup. So this is going to be x squared minus 8x plus 16 equals 0. And now I'm going to refactor. I want two numbers, and it's not going to be 6 and 2, okay, because I want these two numbers to also multiply to positive 16. And negative 6 times negative 2 doesn't equal that positive 16. So I'm going to refactor. This is actually a special trinomial. It's going to be x minus 4 times x minus 4 equals 0. Or another way of looking at that is x minus 4 squared equals 0. So this is one of the parabolas that directly rests on the x-axis, which means there's only one solution, and that solution for this one is x equaling 4. Again, you set x minus 4 equal to 0 and solve for x. So here's another one. I'm going to, just for the sake of it, expand first and then move things from one side to the other. There's no right or wrong on this. So I'm going to multiply this one with this one with this, this with this, this with this. Okay, and I'm going to get 2x squared minus 6x minus x plus 3 equals. And I'm going to do the same thing for this one. So x times negative 2, 1 times x, 1 times negative 2. And I'm going to get x squared minus 2x plus x minus 2. Okay. Now I'm going to move everything, or I'm going to group like terms first, then I'm going to group then I'm going to move things. So this is going to be regrouped to 2x squared minus 7x plus 3, because negative 6x minus another x is 7x. And I'm going to regroup the like terms on this side. So negative 2x plus x is going to just be negative x minus 2. Now I'm going to change sides. It doesn't matter which side I move everything over to. The left and right side are arbitrary. So I always do it so that my x squared is going to be positive. So here's 1x here and here's 2x here. So I'm going to subtract my x squared from this side, which means I'm going to move everything to the left side this time. I'm also going to be a bit cheeky and do it all in one step so that I'm not having to rewrite each line. So I'm going to subtract that. I have a negative x on the right side as well, so I'm going to add x. So I'm going to add x. And I have a negative 2, so I'm going to add 2 to each side. I'm not sick, it's allergies. So 2x squared minus x squared is going to be 1x squared. Negative 7x plus x is going to be negative 6x. And 3 plus 2 is going to be 5 equals. Now everything on the right-hand side canceled out. I'm going to do a fun cancel out. So what's left is a 0. Okay. Now I'm back to my factor brackets. I have a simple trinomial. I need two numbers that multiply to positive 5 and add to negative 6. It's going to be negative 3 and 2. So that means my solution for x is x equals positive 3 and positive 2. And there we go. All right. So the next one says, is kind of working backwards. It's you have, write an expanded quadratic equation given the roots. So it's giving you the answers, okay? So this means that x equals negative 5 is one solution, x equaling negative 3 is another solution. So you need to put it into a bracket that is going to equal 0. So you know that x is negative 5. What plus negative 5 will give you 0? Yay! And then we do the same one with the other one. What plus negative 3 will give you 0? And it's 3. Yay! It's the opposite symbol. Yay! Okay, so that means the quadratic that you could write that has these solutions would be x plus 5 times x plus 3 equals 0. Now, it's not the only parabola that have those solutions. You could stick any number you want, coefficient you want, in front of that factored form of the quadratic. But why? It's not asking you to do that. It's not asking you to have a certain compression or expansion. So don't make it more difficult for yourself. And now it says it wanted an expanded quadratic, so no factors. So now I'm going to do x times 3, 5 times x, and 5 times 3. So x times x is x squared, x times 3 is 3x, 5 times x is 5x, and 5 times 3 is 15. I have two like terms in the middle, so this becomes x squared plus 8x plus 15 equals 0, and we have now just reverse engineered an equation from the solution. Now, the next one is not as difficult as you're going to try to make it out to. Do you remember how if it was something like 3x minus 1 in the bracket, that the solution would be the negative symbol of this? Oops, I said to highlight in it. I must have hit the wrong thing. The negative version of this would go on top, positive 1, and then the coefficient would go on the bottom. Do you remember that? So here you have it, x equals 1/3. You can take the denominator and put it on the coefficient and do the opposite symbol of the numerator. So if that's positive, that means this must be negative. Okay. For the second one, again, the denominator becomes the coefficient and the opposite symbol of the numerator becomes the other number inside. That is another way of doing it. Another way of looking at it is you could do, okay, well, if you don't like that way, you're not quite sure how I did that. Here's one of the solutions, x equals 1/3. So what you can do is you can multiply the whole thing by 3. So you get 3x equals 1. So in order to get that to equal to 0, you would subtract x, or sorry, not subtract x, you would subtract 1 from both sides. So you would get 3x minus 1 equals 0. Okay, so that's the other way to look at it. So let's try the other one. You can have x equals 2 over 3. Multiply everything by 3 to get rid of that fraction. You're going to get 3x equals 2. And then you're going to subtract 2 from both sides, and you're going to get 3x minus 2 equals 0. And that's your other bracket. Now, I actually haven't finished answering this question, to be honest, because it asked for the expanded form. So those are my two factors. So one of my factors is 3x minus 1. My other one is 3x minus 2. They're equal to 0. Now I'm going to use distributive law or FOIL to expand. So I'm going to do 3x times 3x, which is 9x squared. 3x times negative 2, which is negative 6x. Negative 1 times 3x, which is negative 3x. And negative 1 times negative 2, which is positive 2, and it's all equal to 0. Now I'm going to group the like terms in the middle. And this becomes 9x squared minus 9x plus 2 equals 0. And here's my expanded quadratic equation in general form with the solutions provided. Okay. Just going back to the previous question, I just put them in straight into brackets, but you could also do the same style of solution that I showed you with the fractions. So we had x equals negative 5 and negative 3. So if you have x equals negative 5, you're just going to add 5 to both sides. So you get that x plus 5 equals 0. X plus 5 equals, I don't know, I hit the wrong button again by accident. X plus 5 equals 0. And the same thing for the negative 3. You would add 3 to both sides, and you would get x plus 3 equals 0. And once you have those two things equaling 0, you put them in the brackets and multiply and expand out. All right, homeward stretch. Nope, not that. All right, so for this question, to solve a quadratic when rational components are involved, you're going to draw on your skills from the first unit that we did, the radical equations, which was unit 1. Okay? So the first thing you're going to do when you have something like this is you're going to get rid of the radical. So remember, to get rid of the radical, you move the radical, you isolate the radical on one side. Doesn't matter which side it's on, you isolate it. Here, conveniently for 6a, it's already isolated. And you're going to square everything. So that's going to end up with x squared equals, and then squaring something basically negates what the square root is doing. So the square root of 3x minus 2 squared just ends up being 3x minus 2. And now you have a quadratic, and you have a positive x squared on the left side. So I'm going to move the negative 3x, the 3x to the other side. I'm also going to move the 2 to the other side, and I'm going to rewrite it out as x squared minus 3x plus 2. And because everything on the right side got canceled out, that means the right side is now equal to 0. And now I have to factor. It's a simple trinomial. So I can put them straight into factor brackets. And hopefully we're drawing on x, in order for x minus 2 to equal 0, that means x would equal 2. In order for that second bracket to equal 0, x would equal 1. All right. So the next one, we're going to do the same thing. We isolate the radicals conveniently already isolated on one side. We're going to square everything. So the square root of 31 minus x squared just cancels the square root side, goes 31 minus x. And the second part squared, you don't just square the x and square the negative 1 and be like, oop, done. It's the whole thing is squared together. All right, so that's going to end up giving you trinomial square by expanding. Now, this is the same thing as x minus 1 times x minus 1, and you can do your distributive property with them if you need to. But hopefully you're getting to the point with the trinomial squares, especially after completing the square, of just expanding it out. Okay, so now you look at what you have and you have to analyze. What's the best method of going forward? Moving everything to the left side or moving everything to the right side? And the answer here is to move everything to the right side because the coefficient to that x squared is already a positive 1. So we're going to add x to both sides to cancel out the x, and we're going to subtract 31 from both sides. Okay. 31 minus 31 is 0. Negative x plus x is 0. That means my left side is going to equal 0. And now I'm just going to group my like terms. Negative 2x plus another x is negative x. And 1 minus 31 is negative 30. So here I'm looking for two numbers that multiply to negative 30, and those same two numbers add to negative 1. So one's positive, one's negative. The larger one is the negative 1, since they add to a negative number, and they have a difference of 1. Okay, so that means your solutions are x minus 6 could equal 0, so that means x would have to equal 6 in order for that first bracket to equal 0. And you can also have x equaling negative 5, because negative 5 plus 5 equals 0. And there's your solutions. All right. So here is a longer question. We're going to go through it. Hopefully I have enough room for it. If not, I'll have to add an extra page and go that way. So example 7, a rectangular garden has the dimensions 6 meters by 8 meters. So here's his garden, or their garden. And it's 6 by 8. Okay. When he wants to build a path around the garden, he has 120 bricks. Oops, this is not drawn to scale. He has 120 bricks. How wide is the garden? So you're going to assume that the distance across is even all around the garden. Now, I forgot to say that in the question, but you need that in order to solve this question. So that means the total length of this part with the garden plus an x on one side and x on this side, the total, I guess, width, sorry, would be 8 plus 2x. And the total height, width, would be 6 plus 2x, because there's an x here and an x here, so the total length would be 6 plus 2x. We know that the total area of the garden, of the bricks is 120. So we need to find the total area of the big box and subtract the area of the small box, because the area of the small box is not going to be tiled. So we can do this one right away. The area of the small one is going to be 6 times 8. The area is going to be 48 meters squared. Okay. The area of the big rectangle is going to be 6 plus 2x times 8 plus 2x. So that whole thing is the area. I'm going to just rewrite this a little bit differently so I can fit everything on. The area of the big rectangle. And we're going to subtract the area of the small triangle. And that should give us the area of the brick, which I'm just very unhelpfully coloring blue here. Okay, and that equals 120 meters squared. That was given to us. Okay. So to solve this problem now that we've set it up is really no different than what we've been doing before. We're going to expand everything. We're going to group all our like terms. We're going to move everything to one side, and then we're going to factor and solve. Okay. If you like, pause the video here and see if you can do it on your own. All right. 8 times 8 is 48. 8 times 2x is 12x. 2x times 8 is 16x. And 2x times 2x is 4x squared minus 48 equals 120. 48 minus 48 cancels out. I'm going to rearrange as well, write my 4x squared first. Grouping these like terms, so I have 12x plus 16x is going to give me 28x, and then it all equals 120. I'm now going to subtract that 120 from both sides, and I'm going to rewrite 4x squared plus 28x minus 120 equals 0. I'm now not going to forget that incredibly crucial thing that you need to do, which is first look if there's a common factor with all three terms before you factor. So all three of these, 4, 28, and 120, are divisible by 4. So if I take 4 out of the picture, I don't know why it keeps doing that, it's really annoying. That means I'm going to have x squared plus 7x minus 30 equaling 0. Now I have to only factor a simple trinomial. So I'm looking for two numbers that multiply to negative 30 and add to positive 7. So the larger of the two is going to be the positive one, and the smaller is going to be the negative. And so the numbers are going to be 3 and 10. That means in my solution, x can equal either 3 or negative 10. Now, in order to think about this, what is x? X is the width of the path, which is what we've been asked to find. How wide is the pathway? Can it be negative 10 meters? No. So we discard this. I can't fit discard very easily in here. I'm going to try for you guys. All right. That means the width of the path is 3 meters. And ideally, you would write that out in a sentence. The width of the path is 3 meters. So I'm going to do that because I feel like I should, but I don't have room to do it because I'm writing with my finger because my stylus is terrible. So the width of the path is 3 meters. If you're given a word problem, generally you have to answer with words and units. So I'll just put the answers 3. Well, 3 what? Guinea pigs, marshmallows, it's meters, okay. Okay, I got very flustered with the terrible, atrocious grammar of my example 8 that I'm just gonna chop in and re-explain this one. So example 8 should read, find the value of k if one of the roots is 5. So that means that if you were to put this one and factor this one of the roots is x equals 5. That means one of the roots has to be x minus 5. And it's asking, what is that other number? Well, actually, you need to find out what that other number is in order to find out what this number would be. So going back to the simple trinomial factoring, you need to find two numbers that multiply to give you that last number, which in this case is k. And those same two numbers have to add to give you that middle number, the coefficient of the middle term, which is -3. And once you find those numbers, you plunk them straight into your factor brackets. Well, in this case, I already know what one of those numbers is. That number is -5. Okay. So now I have to think, well, what plus -5 is going to give me -3? And the answer is 2. Another way to solve for this is you could add 5 to both sides, okay? And you would get this blank equals -3 plus 5, which is 2. So that's how you would find that this number has to be a 2. I'm just going to erase this because of space issues. Okay. So that means that this number also has to be a 2. So what will k equal? K will equal -5 times 2, which means k will equal -10. For the second one, it's the same idea. It's still the root is 5. So you know that something minus 5 is going to be multiplied with something else, and it's going to equal 0. Again, because we know that the solution is x equals 5, and so we're kind of working backwards. So we now need to find two numbers that multiply to +40, and those same two numbers need to add to k. We know that one of these numbers is -5 because the solution for x is +5. So that means one of these numbers is -5. And we have to go, well, what times -5 will give us +40? And the answer, I'm hoping you get, is going to be a -8. So it's going to be -5 times -8 is +40. And that means if this is -8, -5 plus -8 is going to give us -13. And that means k equals -13. I hope you found that helpful. Please ignore this part of the assignment. What I'd like you to do is try these questions here on page 229 in the textbook. If you don't have the textbook, you can access it online. Thank you for joining me. Again, hope you guys are doing well. Have a great day and see you later.